First step, checking the cable. Before starting the repair, the complete cable must be unreeled and checked visually. The criteria are coat damage, where humidity can penetrate, and bends. Then check the wires on interruptions and short circuits. Either check all the individual wires by a measuring instrument or connect the cable directly to the control unit. Move the cable at the suspicious parts. Close to its connectors, the cable's condition is especially critical. Then cut off the cable at a safety margin of approximately 2 meters away from the damaged part. Check the cut for humidity and possibly shorten the cable again. Be very critical when checking. For safety reasons, better cut more suspicious cable length off than too little. Please check also carefully whether the remaining intact cable length corresponds to your needs. If you have to cut off more than 20 meters, please adjust the control unit due to the new cable length. It is up to you to decide on repairing the cable or replacing it. A cable failure can cause further damages at the control unit, the crawlers, or at the cameras. Now clean all the connector parts and check whether the locating noses are aborted or worn. Is the pressure spring broken? Check also the connector contacts for being non-corrosive and look for the interlock groove at the bayonet lock. Also check the interlock pins at the counterpart. Check all frets for damage. Clean and degrease them carefully. Renew in every case the PG cable clamp nut with protective rubber boot. The rubber squeezing seal and the O-ring 17 x 2.0. After cleaning it carefully, the brass seal is reusable. If the meal connector is pored, it has to be renewed also. Second step, the repair. Cut off the cable vertically. Check again for humidity and then attach all the following parts in the mentioned order. Firstly, the PG cable clamp nut with shortened protective rubber boot. Secondly, the brass sealing ring. Thirdly, the rubber squeezing seal. Fourthly, the connector end piece D9. And fifthly, the bayonet lock ring. For stripping, bend about 4 centimeters of the cable length. At the bend, cut in the sheath with the scalpel now, but without damaging the underlying isolation. Then, after the length, cutting in the cable sheath longitudinally, cut the cable covering off using a side cutter and remove it. Separate the Kevlar threads with a scalpel and then cut off the foil isolation precisely. Open the coax cable by bending the other wires. Cut off the outer coax isolation layer as deep as possible. The isolation layer following is to cut 2 mm over the cable sheath using a soldering iron split. Then take off the isolation. Here's a note. When cutting the isolation by a scalpel, the guarding network can be damaged easily. Therefore, please use the soldering iron split. After that, remove possible soldering remains from the coax sheath. Caution! If the coax cover is brittle, cut off another 2 meters of the cable length and strip again. Now disentangle the coax cover carefully. Twist the wires together and provide it by a heat shrink sleeve being 18 mm long at a diameter of 1.6 mm and shrink it now. Put soldering tin onto the wires and shorten them, leaving 1.5 mm for soldering. The coax core should be the same length as the shield. For that, remove the core isolation about 2 mm over the remaining coax shield using the soldering iron. Provide a 1.6 mm heat shrink sleeve and shrink. Then, provide the core and the shield by a heat shrink sleeve being 5 mm long at 3.2 mm of diameter. Shrink over both of them to insulating also the coax shield's lower end. Here's a note. During shrinking, do not damage the other wire's isolation and do not overheat. Cut the thicker wires down to a length of 13 mm. These are gray-black, gray-blue, white-black and gray-red, but not white-red. The thin wires are blue, yellow, green, white, brown, pink, gray and red. They will be cut off to the same length as the coax core and the coax shield are. Now strip all wires except the white-red one at 1.5 mm and tin them. The greased O-ring will be inserted into the groove of the mill connector. Then the bayonet union is pulled over the mill connector and it is locked by the plug protection dummy. Clamp the plug protection dummy and the connector using a vise and tin the connector pins. Then turn the plug protection by 90 degrees to the right. Clamp again using the vise, getting free access to the soldering pins. Then cut 13 pieces of the 1.6 mm and 2 pieces of the 2.4 mm heat shrink sleeve, getting pieces being 9 mm long each. Put a 1.6 mm heat shrink sleeve piece over the wires and solder them to the corresponding pins. Then move the heat shrink sleeve over the soldering point. Here's another note. While soldering, use a position assistance for the cable or lead the cable over your shoulder. Doing that, an even and axial cable supply is made sure. Start with pin G, then move upwards, getting best soldering axis respectively. After pin G, solder pin F, then H, J, T, S, E, U, R, D, L, P, C, and A. Then shorten the wide red wire to the same length as the rear end of the milk connector. Strip 1.5 mm of the wire and tin it. Provide a 1.6 mm of diameter heat shrink sleeve onto the wire and solder it on pin B. And please check all soldering points and remove possible soldering remains. After soldering, please check the cable's function using a multimeter, finding out possible failures immediately. Third step, connector assembly. Before screwing on the plug cover, the previously recleaned and degreased mill connector thread has to be dabbed with a thread locking agent Loctite 243. This ensures the required sealing and twist protection. Prior to sliding on the plug cover, the cable strands must be pushed together, avoiding damaging of the plug cover's thread. By unscrewing and rescrewing the thread once more, the complete distribution of the Loctite 243 agent can be ensured. Several threads must be completely filled. Afterwards, tighten the plug cover by hand. Never use a tool to avoid tearing off of the crown. Now press the rubber seal into the connector cover. Here is something important. The rubber seal should be lubricated with O-ring grease to avoid cable twisting when tightening the PG screw, otherwise contact inserts could be pulled inside. Now slide on the PG screw, tighten by hand, retighten with a size 20 open-ended wrench, whilst holding the plug cover with a size 25 open-ended wrench. Then tighten the PG screw up to the stop. In the meantime, remove the excess Loctite locking agent between the bayonet lock ring and the connector cover using a paper towel. Here's a warning. Always check the mill connector front side, making sure the contact inserts have not been pulled inside when tightening the PG screw. Should this be the case, the plug must be renewed completely. The finished connector has to be dried for at least 2 hours. It has not to be exposed to any moisture during this time. Finally, the clamp for the strain relief has to be attached to the cable. Connect the cable to the crawler. Then set the 2 half shells of the clamp onto the cable and tighten slightly with all 4 screws so that the shells can be still lifted. The distance between the connector's end and the clamp is approximately 15.3 centimeters. Now tighten all 4 screws firmly and check whether the clamp can be inserted easily into the strain relief's cup. Then remove just screw by screw, leaving the remaining 3 ones securely attached. Moisten this screw using Loctite 243, put back and tighten again firmly. Do so with all 4 screws. This helps to maintain the clamp's position accurately. Now the repair is completed and we wish good luck.